Unit 3.5, System with 3 variables. So the class objective in this unit is to solve systems in 3 variables using elimination and substitution. I hope you still remember these 2 methods that we learned from Unit 3.2. So this unit basically is an extension of Unit 3.2. In Unit 3.2, we solve a system with 2 variables, but this time we have 3. In order to solve a system with 3 variables, we have to learn one important concept, which is equivalent system. Now let me give you an example of what an equivalent system is. Say if you have an equation 2x plus 3y equal to 5. Since it's an equation, when we do something to the left, we have to do the same thing to the right. So if we times the left side by a factor of 2, and we have to do the same thing on the right hand side times 2 as well. So you end up getting, remember distribution, we have 4x plus 6y equal to 10. This new equation, quoted new, is actually the same as this one. That's what we call equivalent system, because they are exactly the same. Even though the number are not the same, but they represent the same line, they represent the same thing. Let's start with elimination first. Here's the questions. Here's a system of equations. We have 3 variables right here, which is x, y, and z. And here is just the label, this 1, 2, and 3. Just the labeling of these different equations so you know which one is which. In the following passes, when you have a question like this, try not to jump right into the calculation. Try to analyze the questions a little bit before you start. So when I take a look at the whole system, I know I'm going to eliminate this one first, the z first, because they all have the coefficient of 1. Here is step 1. Because I want to eliminate z, so I put these 2 equations together first, 1 and 2. And since I see there's different sign before these 2 z, the first one is plus 1z, the other one is minus 1z. So the operation between these 2 equations, I'm gonna use addition because they have different sign. Once we add everything together, so 4 plus 11 is 15, and minus y plus 3y, we have positive 2y, and 2x plus x, we got 3x. So the first one, after we do the elimination, we have a new equation number 4. Now in the equation number 4, we eliminate the z variable. And then we pair up the other 2 equations, 2 and 3. This time, because they have the same sign before z, so instead of addition, this time the operation I'm going to use subtraction because they are the same item. So minus z minus z going to be 0z. That's how we eliminate z. So right now x minus, remember the notation, the operation minus here. So x minus 4a, we got minus 3x. And 3 right minus plus y, we got 2y left. And 11 minus 14, we got negative 3. Now we have 2 new equations, 4 and 5. We're going to make use of these new equation 4 and 5 in the next step. Here's the second step. Now that we have the new equations 4 and 5, we're going to make use of them. Let me grab my pencil. Move this away too. So lucky us, because we have both 3x and negative 3x in the new equation 4 and 5. All we need to do is just add them together. Well, same logic, because they have different signs. One is plus 3x, the other is minus 3x. So we use the operation addition instead of subtractions. Because once we add them, the x variables is going to be eliminated. It's gone. 0x basically. So 2y plus 2y we got 4y, 15 plus -3 we got 12, and then we divide it by 4 on both sides, we end up getting y equal to 3. Once we got y equal to 3, we can substitute to equation 4 3x plus 2y. Instead of y, we're going to substitute 3, the value 3 right here, then we can solve for x. This is plus 6, so minus 6 on both sides, we get rid of the constants. So we got 3x equal to 9 divided by 3 divided by 3, x equal to 3. Here is step 3. Once we know the value of x and y, we can just substitute the value of x and y back into any of these equations we do. So in this example, they just use equation 1 to solve for z. So all you need to do is just change the value of x to 3, y to 3. That's what we got from the last PowerPoint slide. And then we solve for z, which is equal to 1. Then we have to write the solution in the form of ordered triple, which is like this. So this is the value of x, this is value of y, and this is value of z. We are done. The example I showed to you in the last PowerPoint slide is relatively simple because, take a look. Here, all the coefficient for this z variable is 1, 1, 1. So we can start to solve the whole system by doing the elimination right here. But when you have a system like this one, look, they have common y, but they don't have another common y right here. They have x, x, but we don't have another just one x right here. So if you have system like this, we have to come up with something else to solve it. This is what we call an equivalent system. Now I'm going to show you how to make use of equivalent system to solve a system of equations like this. So first, take a look. The equation 1 right here, we're going to change it to this equation by multiply -1 for the left hand side. Well, because this is an equation, when we do something on the left, we have to do the same thing on the right. So that's why you come up with this, because you do distribute -1 times x is -x, -1 times y, -y, -1 times 2z, you got -2z, -1 times 3, you got -3. But remember, these two are the same equations. That's what we call equivalent. They are the same. The reason we do this is because we try to get a right here. We are not going to change anything in the equation 2 because we just want to get rid of y by adding these two equations together. So by adding these two, you end up getting x. Now y is gone, and we have z level 1 because minus 2z plus 3z, we got z. So we got new equation number 4. Okay, let's take a look at the next step now. We make use of the equation 2 and 3 this time. So for equation 2, we multiply both sides by 2. Because it's an equation, if we do something on the left, we have to do the same thing on the right. So you end up having 4x plus 2y plus 6z, and then you have 7 times 2, you have 14. The reason we do this, because we want to get rid of 2y. So there we have only x and z left. So in this case, we didn't change a thing on equation 3, we just copy everything back here. Now we use, again, addition. So 4x minus x plus minus x, we got 3x, and 2y plus 2y plus minus 2y, we get 0y. So the y is getting rid of. And then 6z plus 7z, we got 24. Once we have two new equations 4 and 5, we try to make use of these two new equations by putting down here. and then we're gonna multiply the equation number 4 by 3 on both sides to be exact by -3. So if you times negative on the left, you're gonna do the same on the right. So we end up getting negative 3x minus negative 3z. The reason we do that is because we want to get rid of x so we can solve for z. So in this case, I'm going to do addition again because they have different sign here. So negative 3x plus 3x, we end up getting 0x. And then negative 3z plus 7z, we get 4z. So since 4z equal to 12, we divide by 4, we divide by 4, we end up getting and we end up getting c equal to 3. Once you know the value of c equal to 3, you can use any of these equations to solve for the other variables. So this one, they just pick the equation 4 right here and try to find x. So we know x plus 3 equal to 4. 3 is c. So x equal to 1. So once we got x and z, we can solve for y as well. So he's gonna pick the first one, x plus y equal to z equal to 3, to solve for y. So we just plug in the x value, which is 1, z value, which is 3, and solve for y, which we end up getting negative 4 right here. So the solution, we have to write in order triple like this. And this one, of course, represent x, the first one, and this one represent the value of y, and the last one is c. We can always do the check work by putting all the x, y values into the original system, which is this, to check if they are true. Remember, the solutions of a system means when you plug back all these values in the original equations, it will make all the equations come true. Obviously, it is true, so we're done. Remember, there's no set rule or step for you to solve this type of system. That's why it's challenging. You have to do a lot of practices to figure out how to do that. Now let's take a look at how to use substitution to solve a system. So here's the question. Step 1, we have to find a variable to substitute for. So this time we pick this one because it's a whole lot simple. You just have two variables in this particular equation, and x, you just have 1. The coefficient is 1, so it's easier to solve for x. So we can use x equal to something to do the substitution. So in this case, we solve for x. So x equal to 9 minus 5y. So all you have to do is just isolate x by minus 5y on both sides. So you end up having 9 minus 5y. Once we know x equal to 9 minus 5y, now we can substitute all x with 9 minus 5y, just like this. And then we put it into this third equation. For z minus 5x, we are doing the same thing. You substitute x with 9 minus 5y. So we distribute, we get 18 minus 10y plus 3y minus 2z. You simplify the whole thing, we end up getting a new equation, which is minus 7y minus 2z equal to negative 19. And we do the same thing here, we do the distribution. Watch out for this sign, because minus minus we end up getting positive. So after we simplify, we have the new equation of number 5. Now that we have these two new equations, we're going to make use of it to solve for y. So remember equivalence system. All we did here in equation 4 is multiply by 2 on both sides. So I multiply by 2, the whole thing multiplied by 2 on the left and multiply by 2 on the right. That's why you end up getting 38 here, and this one, you do the distribution again, 2 times negative 7, we got negative 14y minus 4z. we didn't change anything right here because we just want to get rid of the z. That's why we multiply by 2, because 2 by 2, 2 times 2 is equal to 4. The same coefficient right here with different sign. Now we just do the addition right here, and minus 4z plus 4z, z is gone. Minus 14y plus 20y, you got 11y. This one minus 38 plus 49, you got 11. So divided by 11, y equal to 1. Once we know the value of y equal to 1, we can substitute back into equation 4, or you can do that with equation 5 as well. The reason we pick equation 4 because the number is smaller here. So, but if you use equation 5, it still work. So you substitute y equal to 1 right in the equation. Okay, y equal to 1 right here. So we simplify the whole thing. Minus 7 minus 19. So I plus 7 here. I plus 7 here to isolate z. So I end getting negative 12. So right now I divide by negative 2. I divide by negative 2. Negative divided by negative, we have a positive number right here. Negative 2 divided by negative 1. Of course, we end up getting 1. So that's why c equals 6. So we finished finding the value of y and z. The last variable that we have to solve for is x. Right now, since we know z and y already, we can just use any of these equations to solve for x. Of course, I try to find a simple one, which is 2. Because there are only 2 variables in this particular equation. So, because y equal to 1, I substitute y equal to 1 right here. And then x plus 5 equal to 9, so minus 5. I isolate x minus 5, x equal to 4. And we're done. The solution has to be written as an order triple like this. And then we're done.